Hi everyone, I'm Vihan Chakraborty and today I'll be discussing LeetCode's problem number 78, that is subsets. So this is LeetCode's February 22 challenges day 13 problem and this is a medium level problem. Okay, so let's check the problem. Given an integer array nums of unique elements, we need to return all the possible subsets. Okay, so it must not contain any duplicate subsets and we can return in any order. So this is important. We can return in any order and it must not contain any duplicate subsets. So like we're returning 1, 2, 3, we cannot return 2, 1, 3 or 3, 2, 1 like that. So a permutation of a subset is not allowed. So we have to return only one. So now how do we solve this problem? Now there are multiple ways like backtracking and recursion, but today I'll be discussing a way called bit masking. Okay, so I hope you are familiar with this technique. So this is using, so here we will be solving the problem using bits. So let me show you an example. For the first number 1, 2, 3, okay, 1, 2, 3, we have three numbers in the array. So let me take a binary number, initially 0, 0, 0. Okay, so now whenever we have a 1 in this binary number, we include that particular number that is corresponding to this index. We add that number to our resulting set. Okay, so initially all are zeros, so we add an empty subset. We add an empty subset. Now we will make this one. Okay, and just observe, I'm just incrementing the values. Okay, I'm not just like doing anything. Initially it was 0, so 0 plus 1 equals to 1. What's binary of 1? 0, 0, 1. So now the first one LSB is 1, so I take 3 and put it here. 3. Okay, the rest are 0, so I don't put 1 and 2 here. Now moving to the next one, I increment this number to 2. So what is the binary of 2? 1, 0. So 0, 1, 0. So I put 2 in there. Okay, now 3. This becomes 3. So 0, 1, 1 is the binary of 3. So these two numbers are present, right? So 2 and 3. So 2 will go there and 3. Now 4. 4 is 1, 0, 0. That means 1 will go there. Okay, 1 will go there. That's it. Now it becomes 1, 0, 1, that is 5. That means 1 and 3 will go there. 1 and 3. Yeah. So after that 1, 1, 0, that is 6. So 1 and 2 will go. After that it becomes 7. So all of them are 1s. So all of them will go. 1, 2, 3. Okay. So this is the problem, and here we have all the subsets required. Okay, so once we have this, we can store this whole thing in another array and we can return that. So we have to return list of integers. So these are the lists of integers. We can store that in a single list and return that. Okay, so this is the problem. Now one observation is that how long do we keep adding the numbers, like increment this number? Okay, so I started from 0 and I came up till 7. Why not 8, 9, 10 like that? That is because this is where we can have all the permutation of zeros and ones from starting from 0. Now what is this number? This is 7, right? So I can see that this is 2 to the power 3 minus 1, right? Okay, let me write it like this. 2 to the power 3 minus 1. 2 to the power 3 is 8, minus 1 is 7. So where did this 3 come from? This 3 is the length of nums. Okay, it is length is 3. So I do 2 to the power 3, but 2 to the power 3 would give me an extra bit. Okay, 1, 0, 0, 0. 8 has 4 digits in binary representation. So I'm decrementing 1. So starting from 0 to 2 to the power n minus 1, where n is the length of the array, we can have all the permutations of zeros and ones in that number by incrementing it by 1. Okay, so keeping that in mind, let's jump into the code. So len is the num's length and n is this binary number. Okay, so here it is decimal, but we can like imagine it as binary here. Okay, so just don't confuse between length and n. Okay, n is the masking number, bit masking number, and len is the size of the array. That's it. Len won't be changing, it's constant. So after that, this is our answer. Okay, this is our answered array, that is a nested list, and initially we add an empty array into the answer. So this one, we add this one initially. Now what we check is until n is greater than 0, that is we are starting from the end. In the example I started from 0 and incremented the value. This time I am starting from the end and decrementing the value till we are at 0. Okay, so n equals to, this means 2 to the power length. Okay, so I've written using bitwise operator, but this is 2 to the power len. You can do that as well, minus 1. Okay, so here for this example it gives me 7. So until 7 is greater than 0, we stored n into temp. This is a temporary variable that we use to traverse the binary number. Okay, so I equals to len minus 1, and this is a result array. This is the subset. I'm like I'm declaring the subset here, an empty subset. Then I'll be pushing the numbers in this loop. Okay, so what I'm doing is, suppose I have a number at some point. I have suppose 101. Okay, this is 5. So suppose I have this number at some point, temp equals to 5. So until temp is greater than 0, I am checking whether temp bitwise and 1 is greater than 0. So doing this, that is doing this, will give me what? It will give me 1. Why? That is because this one and this one, doing bitwise and of these two ones gives me 1, and I can write this one as 0 0 1, right? So bitwise and of 0 and 0 is 0, and bitwise and of 0 and 1 is also 0. So the answer is 0 0 1, that is in decimal form 1. Okay, so I have 1. So it doesn't matter whether I have 1 or not, because like always I'll be getting the answer as 1, because I'm doing the bitwise and with only a single digit, and that is the LSB. So it will be checking only the LSB and rest will automatically be 0 here. I hope you are getting my point here. So if I'm checking if it is greater than 0, or you can write equals to 1, then we are adding the result of nums of I. So what is this I doing here, and what is this temp doing here? Temp is for checking the bits, okay, for checking every bit, and I is keeping the index through which we can access the nums array. So observe very carefully here. I'm doing 2 to the power of length minus 1 as n, but number of digits present in this number n is always this len, right? If you see 0 to 7, what was 0? It had 1 digit, and what was 7? 1 1 1. So maximum digits present there was 3, which is len. Okay, so number of digits in the binary number will always be equal to length of the array. So keeping that in mind, I can say that I equals to len minus 1, that is it points to this LSB, len minus 2 would point to this, and len minus 3 would point to this. But I is not doing any bit masking here, it's just for the reference. Okay, initially I am checking the LSB through here, and if LSB is 1, then I am adding the last index, the number at the last index of the array, into my result. Okay, so what we do then, we right shift and remove this number. Okay, we remove this number, so my temp becomes 1 0 now, that is 2. Okay, now I again do this condition, if 1 0 and 1, this also gives me, okay, so sorry, it gives me 0, right? So if it gives me 0, so I don't add this. Okay, this one is skipped this time. Now what I do, I decrement the value and remove this digit as well. So 0 is removed, I have 1, and this I again check 1 and 1 equals to 1. So what I do, I use this I, and observe one thing, initially my I was 2, len was 3, len minus 1 was 2. So initially 1 0 for 1 0 1, what was there, the first LSB was true, LSB gave me this condition was true. So I put nums of 2 into my result, so nums of 2 was 3. Okay, so after that I removed the LSB and I decremented I. So I was pointing to 2 and LSB was 0 from 101, the second bit. So after that we check, and this was false, so we remove that second digit from the mask and I decrement I again. So I points to 1 now. So if this bit gives, if the mask bit gives me true, then I put this 1 into the answer. Okay, so that is the solution here. After doing this loop, I have a result subset for that mask. Okay, so after I have the subset, I put that whole subset into the answer and decrement n by 1. So currently, initially I will be starting from 7. So everything happened here was for 7. For 7, I am checking each and every bit and checking whether that's 1 or 0. If it is 1, I am putting the corresponding value into the array. And after that, once I've traversed the whole 7's binary form, I decrement the value and it becomes 6. So then I again check all the digits of 6, that is 1 1 0. So 0 then 0 then sorry 0 then 1 then 1. After that I make it 5. So 5 is 1 0 1. So I check 1 then 0 then 1, then it becomes 4. So then I check 0 0 1 like that. Okay, so this is the problem, and at the end we simply return the answer, that is this one, list of integer. Okay, so I think I could make it clear for you guys, but if you have any queries or doubts, please comment down below. And if you have liked my explanation, please like the video and subscribe to my channel. And yeah, see you in the next video.